We're going to determine the solution to the system x plus y equals 3, y plus 2z equals 7, and 8x plus 3y minus 10z equals 62. And specifically, we'll determine whether this is a consistent or inconsistent system. Because we have three planes, what we're going to do is ask ourselves the first question first: are any of the normals parallel? Well, we look at our current situation and we see that none of those normal vectors are parallel, which means that there are three possibilities. We either have one point of intersection, one line of intersection, or an inconsistent system, in other words, a triangular prism. So let's figure out which of those situations we have. We solve the system using matrices. We want to multiply the first row by 8. Leave the second row alone because we already have a 0 in the spot that we want it to be. And we leave the third row alone. And at this point we can subtract row 1 minus row 3 as well, reducing row 1, in other words multiplying it by 1/8 and getting it back to what it started as. So when we follow those steps through, we get this as the next line of our matrix. The next thing we can do is try to get a 0 value to be here. So we're going to multiply row 2 by 5. And now we're in a position to subtract row 2 minus row 3 in order to get a 0 in that position right there. And we do that, but we end up with a problem. We see that our last line indicates 0x plus 0y plus 0z equals 73. That's impossible. Okay, the last line reads 0x plus 0y plus 0z equals 73. Therefore, there are no solutions, so it is an inconsistent system. The only possibility of the three that we provided at the start, point of intersection, line of intersection, or triangular prism, the only one that had no solutions was a triangular prism. So that's what we have.